everyone. Today we are revisiting some concepts from experimental design from back in chapter 2, and we are going to learn how to run a hypothesis test to answer questions regarding consistency. So here's our scenario for today. Mike is a member of the high school golf team and is considering buying a new club, hoping it will make his shots more consistent. To investigate, Mike decides to conduct an experiment. He will use his current club and borrow a teammate's club to see which of the two clubs make the distance he hits more predictable. So in other words, more consistent. So first, let's identify the treatments. So this is kind of like a recap or review from chapter 2. The treatments. What would be the treatments in this scenario? There's two of them. One is going to be his club, and the other treatment is going to be his teammate's club. The explanatory variable. What is the researcher changing or manipulating in this scenario, in this experiment? Well, they would be changing the type of club. Or you could just write the club. The response variable. The response variable, remember, is the variable of interest. So what are we interested in here? There's a few ways to word it. We are interested in, you could think of it as the consistency of the shot. Or the distance that the golf ball is hit. Is it possible for Mike to be blind in this experiment? So recall the concept of blindness in chapter 2. So remember, we're not blindfolding anyone. We don't need anyone swinging a golf club blindfolded, that's for sure. Blind is basically, does the subject know the difference between the treatments, okay? Does the subject recognize what treatment they're using? Is there any way to hide what treatment they're using? Okay, so for example, if you're trying to test maybe two different cholesterol pills on the market, you can make the pills look the same. So this is kind of totally based on your explanation, okay? If you say, no, Mike is not going to be blind in this experiment because, you know, Mike's on the golf team, so he's probably pretty familiar with the grip of his club, even if the clubs look the same or whatnot. So no, because Mike can tell the difference between the two clubs. If you want to say yes, you would just somehow need to explain that these two golf clubs pretty much look and feel identically. Okay, then he wouldn't be able to tell the difference between the treatments. So I'm thinking, you know, he's on the golf team. He's pretty familiar with his club. So I'm thinking this is going to be no, because Mike can tell the difference between the two clubs. Now, what is a summary statistic we could use to measure consistency? Well, that's where standard deviation comes in, you guys. Standard deviation is a measure of consistency. If you have a small standard deviation, you're pretty consistent. If you have a larger standard deviation, you're less consistent or inconsistent. So here we're going to use the difference in standard deviations. So, one more concept to cover before we go into the hypothesis, more of the hypothesis testing. It's important to note that when we perform this experiment, we are looking at Mike's performances with the different clubs. When we calculate the standard deviation, we're finding the observed standard deviation, which is an estimate of the true standard deviation. So what's the observed standard deviation? It's the standard deviation that is calculated based on a set of performances. The standard deviation that is calculated from a set of performances. True standard deviation. The true standard deviation would be the standard deviation with an infinite number of trials under the same conditions. So true standard deviation only exists in theory. It's kind of similar to like ability. So it would be the standard deviation with an infinite number of trials all under the same conditions. Okay? So let's say the experiment was conducted and the following table summarizes the results. So use the results of the experiment to find the test statistic you describe. So here were the 10 distances hit with the current club, with his current club, and here's the 10 distances hit with the new club or his teammate's club. So you can take a second if you want and pause the video and go ahead and calculate the standard deviation to the nearest hundredth. So that's 2 decimal places. So the standard deviation with the current club, I got to be about 13.56, and the standard deviation with the new club was about 7.72. So remember, the lower the standard deviation, the more consistent he is with that club. So it looks like he's more consistent with the new club because it's a lower value with his teammate's club than his current club. So my difference in standard deviations, it's going to be the standard deviation of the current club minus the standard deviation of the new club, which gives us 13.56 minus 7.72, and that gives us a difference of 5.84. So that is our test statistic. Okay, so let's take a look. At the next step, now we should perform a hypothesis test to see if the observed standard deviation of his performances was because of the difference in ability or rather just due to random chance. So, special note. Instead of saying ability to be consistent in our hypotheses, we can refer to true standard deviation since their meanings are equivalent. Either will be accepted. So however you want to word it is totally up to you. But I kind of like wording it with ability to be consistent. So you're going to see me word it like that. But feel free to reference true standard deviation in your hypotheses as well. So what are the hypotheses we're interested in testing? Remember, it's hypotheses. There's always 2. Our null hypothesis is what we assume is true going into the test. Well, we assume Mike has the same ability to be consistent with either club. Now, what are we trying to prove is true? We're trying to prove that Mike has a greater ability to be consistent with the new club or his teammates' club. So with the new club than the current club. So it says, based on the dot plot of 100 trials, calculate our estimate for the p-value. So, 100 trials, so there's 100 dots here. Remember, go back. What was our test statistic from the first page? Our test statistic was 5.84. So here's 4. Here's 5, 5.5. So right around here. So I'm going to look at all the dots at 5.84 and higher. So remember, I drew my line here because this is 5.84 was my test statistic. So, interpret the p-value. What does this mean? Well, this means there is a 3% chance of getting a simulated, so I'm going to use the label on my dot plot of getting what? A simulated difference in standard deviations current minus new of what value? Of 5.84 or higher by random chance. So, draw a conclusion based on our p-value. So, this was unlikely to happen by random chance. So, the fact that it happened, yeah, I'm thinking Mike is actually really more consistent with the new club. He does have a greater ability to be consistent with that new club. So, first thing you want to do is, remember, always compare your p-value to our significance level, which is 5%. So, since 3% is less than 5%, we do have convincing evidence and remember, which hypothesis do we reference in our conclusions? Our alternate hypothesis. So we do have convincing evidence that Mike has a greater ability to be consistent with the new club then his current club. So we do have convincing evidence that Mike has a greater ability to be more consistent with the new club than his current club. Now, just real quick follow-up question, going back to chapter 3. If our conclusion was an error, what type of error could we have possibly made? Okay, and we run the risk of making type 1 error in this case. Remember, type 1 error is when you have a low p-value or when you accept HA when in fact HO is actually true. Okay? Good luck on your homework tonight, guys.